Hi and welcome to the second video on Year 2 binomial expansion. So in the previous video we looked at how we do expansions and get approximations for expansions when n is rational. And now we're just going to put the final piece of the jigsaw puzzle in, which is how do we deal with situations where we've got that value of a at the front of the bracket not equal to 1. So we are talking about this value here not being 1. Right, okay, so here we go. Now, in the examples we had from the previous slide, a was 1, which is a necessary condition for the expansion to work. And again, there's a whole bunch of stuff going on behind that I'm not going to go into in any great detail here. But what we've got to do is we've got to manipulate our bracket if a is not equal to 1. So we've got a is 1, and then we can do the expansion. So here we go. If we're going to do this expansion here, so this is the expansion of 1 over 3 plus 2x all squared, up to including the x cubed term. And so what I'm going to do to begin with is just take this bracket here and do a bit of manipulating. So if we take out a factor of 3, we've got that. Now it's really important here that we realise that when we take out a factor of 3, this 3 here is still going to have this minus 2, power minus 2 being applied to it. So we're not just going to take it out and then just kind of ignore the minus 2 completely. That's what we've got. The next, when we take out a factor of 3, we should hopefully be happy that if I do 3 times by 2/3 gets me back to 2. So just take a moment to have a look and make sure you're happy with all of that. And now what I'm going to do is use my simple index laws, which is when I've got a power outside a bracket applied to both of it. So I'm going to do 3 to the power of minus 2 and then 1 plus 2/3 to the power of minus 2. So it's that. And we know that 3 to the power of 2 is simply 1/9. What that means I'm now going to do is I'm now going to do this expansion here, which is I can now do because I've got that value there is now equal to 1. And then I'm going to kind of worry about the 1/9 a bit later on. So I'm going to do that expansion first of all. So here we go. So we've got 1 plus nx plus n minus 1 over 2 factorial ax squared. And then we need the cube term, so there we go. We've got the next term, n minus 1, n minus 2 over 3 factorial, and we've got ax all cubed. Tidy that up. So we've got 1 minus 4/3. This term here, so we've got minus 2 times minus 3, all divided by 2, then times by essentially 4 over 9. So that gives us 4/3 as well. And then finally, the last term, all of that stuff there tidied up gives us minus 32 over 27. Right, so that's the expansion of 1 plus 2/3 x to the power of minus 2. The thing we need, this thing here, was that expansion but multiplied by 9. So we've just got the times by 9 to do now. So let's do that. And there we go. There's my expansion. Okay, so on we go. And here we've got an exam style question. This one brings up a whole world of issues. So what we've got to do in the first part is find a series expansion of the cube root of 8 minus 7x. Assembling powers up to including the x squared term. And we've got to do some simplifying. And then in part B, we've got to use our expansion to come up with an approximate value for the cube root of 7,300. Okay, so first things first, let's take the cube root of 8 minus 7x, write it as a fractional power, and then realise that I've got an 8 here. I can't have that. That needs to be a 1. So we've got to take out a factor of 8. Bearing in mind that the power is still applied to this 8. Cube root of 8 is 2. And so now I've got something I can expand. So I'm going to do an expansion of that thing there, and then times by 2 all at the end. So let's do the expansion. So we've got 1 plus n times ax, so the n is 1/3 minus ax, the 7 over 8x, plus n minus 1 over 2 factorial times by minus 7 over 8x squared, and that's as far as we need to go with it. So I've just got to do some tidying up now. So I've got 1 minus 7 over 24x, and all of this bit here tidied up. Now we've just got to be a bit careful with signs again, because I can see I've got a minus here inside my squared bracket. Makes it positive, but then I'm times it by minus again here, so that term is going to be negative as well. So there we go, that's my expansion of my bracket, and then I've got to realise that the actual expansion I need has got to be multiplied by 2, so let's do that at the end, and there we go, there's my value, my expansion. Right, part A done. Let's crack on and have a look at part B. So in part B, we've got to do the cube root of 7,300. Now, in some questions where you're asked to do an approximation in the exam, you might be given a value to use. It might be you've got to choose your own, or what they do tend to do sometimes now is suggest a range of possible values you might use, and you've got to determine which ones are okay to use, which ones are not, which ones might give better approximations than others. So the whole range of ways in which they can test your knowledge and understanding on this one. But in this case, let's start off by saying we need a value of x such that 8 minus 7x, the bit inside the cube root, is 7,300. So the obvious place to start with that would be to make that statement and then solve that. So x is 7,300 minus 8, all divided by minus 7. And that gives you a value of minus 1,041.714. And on we go. Now, you might want to think, well, that's the value I'm going to use for x, but we've got a fairly major problem in so much that we've got our restriction here, which says our value of x has got to be less than 8/7. Remember, these expansions only work for small values of x. And as we can clearly see, this value here is well outside the range of allowable values. So, unfortunately, what we're going to have to do is bin all of that off and start again. So, here we go. Cube root is 7,300. What I'm going to do this time is just manipulate the cube root to begin with. So if I treat this as a surd and say, well, how can I cancel down that surd? I can write that as 1,000 times by 7.3. And I used 1,000. It might be you wanted to go for 100 times by 73, but I've gone for 1,000 because cube root of 1,000 is a nice, easy number to deal with. It's 10. So now what I've got is 10 times the cube root of 7.3. What that now means is, if I say that bit inside the cube root, the 8 minus 7x equals 7.3, that gives me a much nicer value to work with, so that's going to give me x equals 0.1. And 0.1 is clearly well inside the range of values that we're allowed for which this expansion is valid. So, now I've got an appropriate value of x to use. What I'm going to do is plop that into my expansion. So I'm going to do it, first of all, we know that our expansion, there it is, so let's put that value in. So when x equals 0.1, we want cube root of, that gives us cube root of 7.3, and if we put that value into our expansion, we get that. So that means the cube root of 7.3 is 1.93811. So if we know the cube root of 7.3 is that value there, the thing we need is the cube root of 7,300, which is simply 10 times our cube root of 7.3. So all I'm going to have to do now is take my value here, multiply it by 10, and there we go. There's my approximation sorted.